Hey everyone, welcome to this episode of Think, Learn, Do. For this episode, we're going to be revisiting our garage door open detector. If you remember in our previous episode, even in deep sleep, we were drawing about 9 milliamps. For my calculations, with AA batteries, that gives us about 300 hours or 12 and a half days of battery life, which is atrocious. So we're going to try and fix that today. The first idea I had for this is to take this voltage regulator, and you can see I took a surface mount version of it and turned it into a through hole part so we can test it out on my breadboard. This voltage regulator has a quite quiescent current of 60 microamps, which theoretically will, if this is deep sleeping at, like 50 something microamps plus 60 microamps, that's significantly better than 9 milliamps. So we're going to try that out. It's got a simple pin out. Voltage regulators are pretty simple. We're going to have an input where we have a positive voltage in that's like higher than what our device can take. In this case, it's aiming for like 6 volts in, and then it's going to output 3.3 volts. So that'll feed into our microcontroller. And then this is just my wonderful ground connection here. So let's get that hooked up and we'll try it out, see if that can deep sleep a lot better. The voltage regulator is hooked up. And so we're going to have voltage coming in from our power pack. The voltage regulator gets dropped down to 3.3 volts. It's going to go back through our multimeter, which I'm going to have set to measure how much current's being pulled, and then into the ESP. And the idea being that by using this voltage regulator here and bypassing the onboard, that we'll be using less quiescent current, and so when we're in deep sleep, the batteries can last longer. So let's try it out. You can see we're pulling 11 milliamps, which is actually more than before, so that's not going to work. So the other idea I came up with was to try this other voltage regulator. You can see it's got 4 pins. So not only does it have an input, output, and ground, it also has this enable pin here on the end. The idea being that we'll plug this in, and then I'll be able to control this whole subcircuit with this enable pin. So and when the enable pin's got no voltage or ground, it's pulled low, this whole circuit will be off, and then when I turn voltage onto this last pin, the enable pin, the circuit will get voltage. It'll turn on and get voltage and do whatever it needs to do. The idea being that I'm going to have another microcontroller that can pull a lot less current, that can control this and check states on the pins and whatnot. And when the state changes, go and wake it up and it can do its Wi-Fi stuff and turn off. Let's hook that up and try it out. We have our voltage regulator hooked up. This bottom pin here is actually our enable pin. So that's how we're going to control it. Right now I've got it pulled down to this ground rail. So it should be off. So this should be our lowest state where this whole circuit's off. Let's see what this looks like. We're pulling 0.04 milliamps, which is a huge improvement over before. Now let's go ahead and turn it on. Make sure things come back on. We're going to take this over here, and you saw that light flash. I don't know if you saw that, but the light flash, so it turned on. Pulling 13 milliamps. So it's still in deep sleep right now, pulling 13 milliamps, but that's fine. We're not worried about that. We're worried about that when we turn this voltage regulator off, this whole circuit's off, and it's pulling hardly any current. And it looks like that'll work. This next step is going to be a bit more complicated. We're going to bring in this Holtec chip, the microcontroller here. That's going to be checking our tilt switch, which is here. You barely can see it. And then there's also a voltage regulator here that's going to power the Holtec chip. So let's draw this out real fast. I'm going to have my Holtec chip. This is it's the HT68F001. It's a really simple chip. It pulls hardly any current while it's running. It's like 10 milliamp or 10 microamps while it's running. It should be a good fit for this, where I'm trying to have a very low amperage. So we're going to have to power this with its own voltage regulator. Once again, it's pretty standard input, output, ground. And this is a pretty tiny quiescent current microcontroller or voltage regulator as well. I think it's an 8 microamp quiescent current voltage regulator, so that'll hopefully help us keep that down. Then I'm also going to have our tilt switch, right? Now the tricky part is, and then we're also going to have another voltage regulator. This is going to have our enable pin. So what's going to happen is, and this is by no means accurate, but we're going to have power and ground going to our Holtec here, and then it's going to be able to have one of these GPIOs over here hooked to the enable pin so it can control when this is on. And this is going to be powering our Node MCU over here. And then we're actually going to have another pin coming up here going to this tilt switch. And the Node MCU is also going to be able to check the state of this tilt switch. And this just goes to ground because we're doing input pull-up on both of these. The idea being that with these both input pull-up, when the switch is not open and the ball's up at the top, they're both going to read the high voltage, and then when it's down, they'll both read the ground voltage, or ground. And then one last thing, we could probably come up with a better way to do this, but we're also going to have a pin here connected to the Node MCU. Once again, it's input pull-up, and this is just going to be other GPIO set to output. And what's going to happen is the Holtec is going to detect that the state has changed. It's going to turn on the enable switch. The Node MCU is going to turn on, check the state, and then report that over Wi-Fi, right? Now the Holtec won't know when the Node MCU is done. So by setting up this line here, it can watch this line, and when the Holtec, or when the Node MCU brings this line low, it'll know that it's done, and it'll take this enable pin low and then go back to sleep and keep checking this until it changes again, and the cycle starts over again. And the goal is by having this be the only circuit that's on all the time, we pull very little current and our batteries can last more than 3 days. Alright, I think I have the circuit all hooked up correctly. Let's see what this does. And once again, we have our power coming from these batteries. It's hooked up through my multimeter so I can monitor the entire circuit's amperage usage. And hopefully while everything's not changing, everything's off, and this is the only circuit that's on and it pulls very little amperage. Then we can change it, see this turn on, etc., etc. Okay, pulling right now 0.17 milliamps. Looks like everything's off. Let's try turning our tilt switch to mimic the door coming open. Alright, so we're pulling 100 and something milliamps. Looks like it's turned on. I saw the light flash. Alright, and we're back off again. We're back to, this time, 0.11 milliamps. Looks like my Node.js server got the GET request. That's great. Okay, now let's close our garage door. There we are. It's back down to 0.17 milliamps. And once again, our garage door alert was received by the Node MCU, or by my Node.js server. And that delay you notice of several seconds is this microcontroller doing some debouncing to make sure that if the ball is bouncing around, it's only detecting when it's actually open or closed. And so with a 0.17 milliamps, running through DigiKey's battery life estimator with AA batteries, that gives us around 2 years if we just sleep the entire time. So hopefully I would imagine we can get maybe a year out of this, which is significantly better than the 12 days or whatever I came up with before when we were doing 9 milliamps. So that's great news. So the next steps on this is hopefully I can take this and put it into a nice case with some batteries, maybe a circuit board to make it a little nicer looking. And then I'll get it mounted on my garage door. I'm thinking I'm going to use some of the foam double-sided tape, stick on the back of that, stick it on the door, and it will be awesome. And I can't wait to show you guys that. So thanks for watching.